Guys, in this video, we are going to go over properties of solids, liquids, and gases and talk through phase changes. All right, so guys, we're going to start by talking about the arrangement. So we're going to start with solids, and next is going to be a little video clip showing you a demonstration of solids.
Okay guys, so you can see this is a visual aid of what a solid particles would look like. So as you can see, they are super tightly packed. And there's really they really can't move very much. So the solid particles just kind of are tightly packed and they vibrate in place or move in place a little bit.
So as you saw in the video, solids are super highly ordered, or we could say like very tightly packed. And so that leads them, since they're so tightly packed, they just are super close together that they can only vibrate in place. So the molecules are still moving, but they can't slide past each other or anything like that. So they just are very tightly packed.
Okay, so this is a representation of a liquid. As you can see, there's a lot more movement that can occur in our liquid. The molecules are able to move past each other, but they still are relatively tightly packed as well.
And then liquids are much less ordered. In a liquid, the molecules are still relatively tightly packed, but they're able to slide past each other, which is how we get that flow in our liquid, as the molecules are able to move and slide past each other. And then last but certainly not least, gases. Show you a little clip of gases now.
All right, and then last but certainly not least, we have our gas molecules. As you can see, they are not tightly packed, they're super loose, so they're able to have quite a bit of movement of the particles.
Gases are super random. They, the molecules move all over the place. So that actually kind of goes into our movement. So gases, the movement is random. The particles, we have a whole unit about gases next semester. But the particles in gases just fly in one direction until they collide with the walls of a container or another gas particle, and then they bounce and they keep going. So the gases' movement is very random. Liquid, their movement, they are able to flow past each other, but due to the forces of attraction, they're called IMFs. Oh, I spelled that wrong. Due to the intermolecular forces between them, they are still pretty attracted to the other liquid molecules, and so the movement is still relatively ordered, but they are able to flow past each other and all of those things. And then solid, gosh, guys, they nearly don't move at all. So nearly negligible on the movement, but they just vibrate in place. But it's so small, the particles aren't sliding past each other or anything like that. Okay, shape-wise, so the shape, solids are going to have a definite shape. So, if I was talking about my pen is always going to be this shape as it is a solid. Liquids, they take on the shape of the container. So, for example, my cleaning spray, it's currently in kind of a cylindrical shape. If I turn it to the side, it changes shape. So the liquid's shape changes dependent on what container they are in. So shape of the container. And then gases is the same thing. They also take up the shape of the container. Okay, next is volume, or how much space they take up. All right, solids have a definite volume. They're always going to take up the same amount of space. Liquids also have a definite volume. So even though their shape can be different, this amount of liquid, whether it's turned this way or this way, the shape changes, but the amount of liquid stays the same. And then gases actually can expand or be compressed, and their volume is actually the volume of their container. Just because of the way the particles are arranged, the particles can, expand out or, be compressed into a smaller space. Next is compressibility. So compressibility, what we're talking about here is ability to squeeze the molecules closer together. So squeeze the molecules closer together and put them in a smaller space. For a solid, it's really almost negligible. You really can't squeeze the particles any closer together because they're already super tightly packed. So they can't really be pushed closer together at all. So it's nearly negligible. I guess theoretically, if you could get them slightly closer, but not really. And then same thing with liquids. Again, the particles are pretty close together as it is. But the thing is, if you put them under that much pressure, they would just turn into a solid. So, so it doesn't work with liquids. But gases are highly compressible. So think about scuba diving. If you go scuba diving, you have an oxygen tank. You've compressed a whole bunch of oxygen gas into that tank. Even an air freshener can or something, or a Lysol spray, relevant to the times, is compressed air, and so it's pushed into that small container. So gases are highly compressible. And next we have density, which is how tightly packed the molecules are. And guys, density is mass divided by volume. Okay, so gases, I'm sure you can figure this out, but their molecules are very far and very spread apart, so they are going to have a really low density. Liquids are somewhere in the middle, so they have a medium density for the most part. And then solids are going to be, since they're really tightly packed, are going to have a very high density. Now there is one exception. Water is actually less dense as a solid than it is as a liquid, which is why ice floats. But that's the only exception, is water is less dense as a solid. And it has to do with the way that the water freezes actually, and we'll talk about that. We have a whole day to talk about water next semester, so we'll talk about it then. Getting you excited. And then the last thing on this chart is forces of attraction. So this is, again, kind of what we call IMFs, and it is the forces of attraction between the different particles. So gas particles have very, very weak forces of attraction. It really, one of the postulates of the kinetic molecular theory of gases, which is basically how gases behave, says that gases have almost no forces of attraction between them, so the molecules aren't attracted to each other. Whereas solids, they are held together very tightly, so they have very strong forces of attraction between the solid particles. And then liquids are somewhere in the middle. They're not nearly as weak as gases, but they're also not as strong as solids, but they're less strong. Okay? So now let's go through our different phase changes. So if we go from a solid to a liquid, that is called melting, or also called liquidification. If I go from a liquid to a gas, that is called boiling. Oh, oops, I gotta change into the pen. Don't want to write in highlighter. Boiling, or also called vaporization. All right, and then our last one on kind of going that way is gas to solid, number 3 there. And going from a gas to a solid is called deposition. It's probably a new one for you guys, so gas to solid. And I always think about deposition is that the gas particles are being deposited into form a solid. That's just how I remember it. But you can remember it any way you want to. All right, and then solid to gas. So that one is called sublimation. Sublimation. And I always think S starting at solid, so starts at solid, goes to gas. Sublimation. Since it starts with S, I don't know. That's just how I remember it. And then from gas to liquid right here, this one is called condensation. And it's not the same condensation as like rain. But it's like if you think about when you have a really cold water bottle or something like that and water forms on it, well, it's condensing. It's the gas molecules in the air hit that cold surface and they turn into a liquid. And then our last one right here, liquid to solid, is called freezing or solidification.